Um, Hi, my name is Artem. I'm one of the deputy CAs at the Uhuru Worlds, and yeah, let's talk a little bit about artificial intelligence. I think that this is a very interesting topic, especially as it concerns debate, because I feel like it is definitely a topic that a lot of people kind of shy away from. They think it's a little bit too technical, um, which really, at the end of the day, I think it's not about the technology, but rather the implications of that technology that are really at issue. And I think that it poses a lot of serious implications uh, that touch just about every sector of society. And I think that these kinds of issues are very important to talk about. So let's get started. A few things that I'll be talking about. First of all, I'll be giving kind of some brief kind of historical context about where we are currently in the state of technology, then giving a brief explanation of what it is and how it works, giving some kind of example applications, and then we're going to take some time to talk about the kind of some of the problems posed by AI and some of the debate applications kind of. So let's start talking about some context, right? I think generally most of us are familiar with how computers work and what they are, right? Historically, computers were actually a job profession, right? Where people got hired to basically sit around and solve math problems all day. Now, eventually we were able to mechanize it and use electronics to create computer systems that did this sort of thing for us. And over time, we basically got to where we are today, where computers are very small, very fast, right? Like the computers that exists on your phone is multiple times faster than the computer that landed on the moon, right, in the 60s, despite the fact that it's a fraction of the size, right, and that's certainly a fraction of the cost. But despite this, computers have generally remained functionally the same insofar as they solve computational problems, right? In other words, they're basically fancy calculators, although they can solve things at multitude, you know, what a human can solve in a year, a computer can probably do in a fraction of a second. Um, so with that, though, we still have kind of some of those same limitations, uh, right? Because while computers are good at computational problems, they're not that great at kind of some of the more abstract problems that are natural to humans. For example, image recognition, right? Now you can probably look at this picture and see, obviously identify that this is a cat, right? And this is something that you don't really have to think about. But for a computer, this problem is very, very difficult, right? Because, well, what makes a cat, right? How does a computer recognize it, right? If we break it into parts, right, and say, okay, well, a cat has whiskers, right? It has like four paws, has like little cat ears, right? Sure, you could do that, but then you're kind of back in that same problem of like, okay, well, what's a whisker, right? How to recognize that. So this is a very complicated problem because there's not really a computational solution, right? We can't really pose this as a computational problem. So computers, this becomes very difficult, right? Same thing goes for kind of complex multivariable pattern finding problems, right? Things like, for example, analyzing, right, what to do next in a stock market, right? Reading the news and seeing, okay, well, this company, right, is having like just released a new product, right? There's a lot of hype around it, right? I should probably invest into that company, right? Again, these sorts of problems that are in some ways innate to humans are very difficult for computers to handle. Again, complex decision making kind of on the same scope, right? And these are kind of the problems that artificial intelligence and machine learning try to address. So what is AI, right? And before I kind of get into this, I feel like it's important for me to talk a little bit about this distinction between artificial intelligence and machine learning. Now, usually both in the debate context and in the context of like reading the news, right, these two terms get kind of used interchangeably, right? However, there is an important distinction there. Now, artificial intelligence refers to basically anything that a computer does that can be considered intelligent, right? And most of these things are very non-controversial in their nature, right? For instance, the Apollo 11 program landing on the moon, right, using autopilot, that is a form of artificial intelligence, right? Um, right, the chess engine that beat Kasparov in the 90s, again, right? a form of artificial intelligence. Even something as simple as like your phone going into a battery saving mode can be an example of artificial intelligence, right? And most of these things are not controversial, right? Now, then we get to the topic of machine learning, which is a part of artificial intelligence, right? And a very big part, and that's kind of the part where we're developing that is kind of at the forefront of work in artificial intelligence currently, right? And this is where kind of most of the controversial things about AI start to take shape, right? This is where we get to like the social media algorithms, right? This is where we get to algorithms that are likely to take a lot of jobs away, right? This is where we're really kind of starting to push against that kind of to the forefront of artificial intelligence and kind of the really clashing directly with some of the societal and economic impacts that come with it. So how does then machine learning work? And I'm going to talk primarily about machine learning here at this part, just because one, it's kind of at the forefront of artificial intelligence. So it should give you a good idea of what the kind of scope and limitations of current artificial intelligence research are. But secondly, right, this is where kind of most of the controversy is. So this is kind of what I wanted to cover. And the basic idea is really quite simple, right? It takes inspiration from the learning process that you or I might go through, right? For instance, let's say there exists some animal that I've never seen before, right? You show me a photo of that animal. Well, now I have some idea of what it looks like, right? You show me 10 photos of it, I probably have a much better idea of what that animal looks like. And kind of the same idea goes here, right? Except this is kind of a more mathematical representation of that problem, right? So what's going to happen, right, to get machine learning working, right, is I'm going to, for example, let's say I want to train a program to be able to recognize different animals, right, and like show it a photo and have it return like, is it a cat, is it a dog, is it a rabbit, etc., right? Well, what I'm going to do is I'm going to have a giant data set of just like labeled photos of animals, right? And then I'm going to feed it into this algorithm. Now, initially, right, the mathematics of what it uses, without going too deep into it, right, are completely random. So the answer it's going to produce is completely random, right? Well, that's not very useful, but then the magic happens, right? Because what I'm going to do is, hey, if it gets an answer wrong, well, I'm going to take a look and backtrack through kind of the math of it, right? And see, well, what guided it to the wrong answer, right? And what guided it to the wrong answer, I'm going to penalize that, right? Then I'm going to look at, okay, well, which parts of this system actually guided it towards like saying that it's a cat, right? And I'm going to slightly bump those weights up, right? And in the end, we actually get a very, very good system for classifying images. But this doesn't just apply to images. It could apply to any set of data. It could apply to financial data, right? It could apply to scientific data, genomics. All of that has massive applications in machine learning. And that's right, which is kind of the basics of how it works. So then let's take a look at kind of some of the applications. First, we'll look at some of the kind of maybe not so great, right? Definitely controversial applications, right? And probably the most obvious one that comes to mind is social media, where companies like Facebook, Twitter, YouTube, etc., use machine learning to increase the amount of time spent on the platform, right? Obviously, they're private businesses. They want you staying on their platform as long as possible because the longer you stay on there, the more ads you see, right? The more you produce revenue for them, right? And some of their applications, even when it works as designed, are kind of problematic, right? Insofar as the algorithm will constantly try to feed you to, in essence, feed on your addiction for information, right? And will always try to kind of provide you with information that you want to see, right? Which is inherently problematic, both because of the fact that, one, just in generally, like, this is addictive, right? But two, right, it will necessarily kind of guide you away from things that maybe challenge your worldview. And obviously that is problematic from just like a democratic perspective, from a perspective of creating an informed populace, right? But secondly, then there's the issue of the fact that a lot of kids use social media. So this kind of This kind of a preying algorithm, right, is also kind of problematic from that sense. But all of that is problematic, but then we get to really the unintended consequences of such an algorithm. Um, and this is where we get to talk about things like, excuse me, right? But this is where we get to talk about things like uh, sowing division, right? Let's say I am trying to get information about vaccination, right? Um, well, obviously, the best source of information would be something that has some scientific research behind it, right? Some scientific backing. The problem, though, is that a lot of that information is very not interesting, or not interesting, I should say, right? But that information kind of doesn't necessarily have the same retention rate as like a conspiracy theory does, right? And this is where we get into a lot of issues, because I might start looking at like New York Times articles about the benefits of vaccination, and then the algorithm is going to suggest, hey, have you taken a look at like this thing about how maybe you should spread out your vaccinations, right? And then you look at that, and then it's like, well, you know what? Maybe vaccinations aren't such a good thing. And then the next thing you know, right, you're looking at articles about how Bill Gates is trying to like microchip your kids, right? And it's like some kind of a wild conspiracy theories, right? And oh, and by the way, while you're looking at that, have you considered the flat Earth theory? Heard they have members all around the globe. I'll let that joke hang there for a second, but you can see how this kind of spirals down out of control, right? And this creates significant unintended consequences, especially insofar as, right, especially when we get then to the political sphere, where, we see the consequences of this are that we create a lot of division in, for example, in politics, right? Like a lot of researchers will attribute increased social media division to things like the rise of the far right movements, right, in recent years. So you see these kinds of problems arise as a result of machine learning use in social media. So definitely a significant societal implication there. Then we get to other uses, right? Things like facial recognition, right? It's used by governments and law enforcement, right? But it's also used, for example, by the Chinese government to oppress the Uyghur populations, right? This is, all of these things are incredibly problematic, right? But even looking at uses that are less obviously, evil and borderline genocidal, uh, right? Even used by your just normal law enforcement, right? On one hand, catching, murderers and rapists is probably a good thing. But on the other hand, the way in which that is done is oftentimes by scraping, for example, social media profiles, right? And using your private information to do that. For instance, there's a company, I believe they're an Australian company, right? That basically what they did is they scraped all sorts of social media, your Facebooks, your Twitters, your LinkedIn, and developed a facial recognition algorithm, and then they licensed it to law enforcement agencies to then get information, to get basically to match faces. And this is incredibly problematic, right? Because they didn't get permission from Facebook to do this. They didn't get permission from any of the people to get these photos and get this information, right? So it's incredibly problematic from a privacy standpoint when we consider the fact that machine learning can operate in such a way where people who did not give their consent to have their information used in such a matter, right, are now getting their information used, right? Especially, we see this kind of erode some of the trust that people have in their privacy. We see this kind of erode the idea that people have a right to privacy, right? Like, because we're now seeing that we're creating this society where, thanks in part to artificial intelligence and machine learning, we have a society where the idea of privacy is slowly getting eroded through the use of these algorithms that are constantly preying and constantly watching on A, what you do, B, like, kind of facial recognition is just one aspect of that. And then another kind of interesting Oh, and by the way, with facial recognition, there's a massive issue with the fact that facial recognition algorithms work really bad with people of color. Right, there's a very high mismatch rate. So then we get to a point where there's a lot of um, civil rights concerns, right? Especially when we concern with like use by governments and law enforcement. And on that same theme, right, is another application that was tested by Amazon for job application screening, right? So Amazon wanted to, obviously you're a big company, right? You get a lot of resumes. So they wanted to develop an algorithm that could basically find the best candidates by looking at the resumes, right? So what they did is um, they took the resumes of their employees, right, the ones that were successful in getting a job there, put it through a machine learning algorithm, right, and basically now anybody who's applying to job at Amazon, right, basically their application goes into this algorithm, right, and the algorithm will tell whether they should get an interview or not. Well, right, and they did this both to screen out the best possible employees, but also, as a conscious effort to reduce bias in their hiring practice, right, which I think we can all agree is a good goal. The problem, though, is that the data set that they used of their employees was itself biased because, well, their hiring practices were biased, right? And the problem is that when you put that into an algorithm, is that the algorithm not only just extended the bias that already existed in the data set, but it actually worsened it, right, to the point where people who are like people of color were literally like getting automatically denied right through this algorithm to the end. It got so bad to a point where this entire program had to be scrapped, right? So you're seeing these kinds of, when machine learning is not used in a proper way, when it's not tested properly, when the data sets are bad, um, you're seeing the implications can be quite negative. Uh, so at the end of all this, right, it's pretty easy for you to kind of see and think that, well, hey, this machine learning technology seems pretty negative, right? But then, of course, there's a lot of also really positive things that come out of it. For example, right, IBM Watson is just one such machine learning system. You might have seen it, basically kick ass at Jeopardy, but that's actually only a part of what it does, right? Um, the majority of what it does, its day job, so to speak, is actually as a question and answer system in a hospital to give advice on lung cancer treatment, right? And certainly it's still obviously in the development phase, but over time, right, this sort of technology can be used to basically provide medical advice to people, right, at a fraction of the cost, and advice that can in many cases be better than what your doctor can give you, right? Why is that? Because, well, this kind of system, right, is obviously going to know more about the various drugs and about the various conditions than any human can possibly do, right? So you're seeing these kinds of positive implications happen. And in fact, this test is so successful with the lung cancer treatments where something like 90% of the medical practitioners who use it will actually follow the advice that IBM Watson gives them. Right, so we're seeing this kind of massive success. Um, of course, another major application for machine learning is disaster prediction and recovery. Um, for example, machine learning models can be used to predict hurricanes and earthquakes and other natural disasters, which can save thousands of lives, right, by getting people to evacuate earlier. It is also often used in recovery efforts. For example, there's actually a machine learning algorithm that can that can analyze thermal data after a disaster to see if there's any people that are trapped, um, and things like that. Obviously, these things save massive amounts of lives, right? So balancing out the negatives and the positives of artificial intelligence really becomes kind of a big deal. The other, of course, positive application is the COVID-19 vaccine, right? Where machine learning is one of the tools that is used to develop the vaccines, and certainly with it being one of the fastest vaccines to ever be developed, right? That's helping that is certainly no small feat either. So then we get to, excuse me, right? So then we get to the question of kind of some of the problems that are posed and some of the debate applications, right, that come with this sort of technology, right? And really, both in talking about AI as well as kind of the debate motion surrounding it, there's three major kind of areas, topic areas that are touched by this. There's certainly other ones that do get touched, right? Especially and certainly the topic areas that surround just the general use of science and technology and kind of the ethics surrounding it most certainly apply. But then we'll be here all day if we had to talk about all of them, right? But specific to AI are kind of these three areas, right? Which is first, what can we trust AI to work on and to do? Secondly, is who can be trusted to actually operate it? Obviously, somebody has to be in charge of it, right? And who that person or that group is obviously a massive issue. And third is a topic that we haven't really spoken about yet, but is another very important topic, which is this idea of economic fallout, right? Obviously, there's going to be some transition in the economy when a significant portion of the jobs are at least taken over by AI, right? And the idea of, well, what happens next is certainly a big topic of discussion surrounding its applications, right? So let's talk a little bit about these things. So first, let's talk about what we can trust AI with. And to this, probably the easiest way to look at it, right, is by kind of looking at the kind of not national, kind of the natural hierarchy that we put, national kind of hierarchy of scrutiny that we put on different professions, on different tasks, right? Obviously, different tasks have different levels of responsibility affiliated with them and a different level of consequences affiliated with mistakes that are made in those tasks, right? For instance, if I go to a store and the shop clerk accidentally accidentally charges me like $5 more than they should, right? Well, I might be a little bit annoyed by that, certainly, but it's not the end of the world, right? I'm not gonna die because I accidentally overpaid $5, right? And even then, I can probably just go back to the store and get that issue sorted out. And so naturally, right, the scrutiny we put on someone working that job is less than some of the other professions, right? For example, if a neurosurgeon makes a mistake, well, people die, right? And so naturally, right, the level of scrutiny that we put on someone who's in the position to be a neurosurgeon is significantly higher, right? They have to go through a significant level of education, pass a significant amount of exams, and right, and also be constantly checked by their fellow colleagues, right, and fellow doctors, right, to make sure that they are indeed qualified for that position, for doing that job, right, and therefore that they're going to be significantly less likely to make that mistake, right, because the need to ensure that they don't make that mistake is just that much higher. And then obviously there are things that are kind of in the middle of that, right? Obviously somebody driving a car, right? Well, yeah, that can be deadly, but that's probably doesn't require the same level of scrutiny. So we have this kind of hierarchy that we created within our society to ensure basically different levels of trust. But then, and when we consider kind of what we can trust AI with, right, it's easy for us to kind of go and say, okay, well, let's take a look at the human equivalents of those jobs, right? Let's see, like, what is the chance that a neurosurgeon will make a mistake, right? What is the chance that an engineer will make a mistake, a driver or a shop clerk, right? And let's compare that with the chance that an AI will make a mistake, right? And then, wherever that falls, then if the AI is better than that person at doing that job, right, then let's replace them with an AI, right? Sounds simple enough. But then that doesn't really, right? And but then that doesn't really mesh with the fact that some of these professions actually require uh, not just kind of analytical skill, right, but also moral skill, right? And something that is important to understand with AI is that machines have no concept of moral values, right? They don't have a moral philosophy by which they lead, right? By which they operate. So then this becomes a big issue when we're talking about trust, right? Take this problem. This is basically a modern version of a Charlie problem that MIT has created as part of their research, and it's called the moral machine problem. You can actually Google it and do this for yourself. Um, but this is a very big problem. If you've been around AI at all, you've certainly heard of it. Right now, understand before we even get into this that autonomous vehicles that are currently being developed in many cases are much safer than vehicles that are operated by humans, right? So if we're just looking at kind of the hierarchy, right, it's easy for us to say, well, okay, autonomous vehicles are much better than people. But then you look at a problem like this and you start to realize kind of some of the issues with just making that kind of blanket assumption, right? Which is the fact that, okay, well, let's pretend I'm driving in an autonomous car and suddenly, for whatever reason, the brakes fail, right? And there's a person crossing the street. Well, what should the autonomous car do? Should it try to save the pedestrian, maybe crash into a wall, right, risking my life as a passenger, right, but saving the life of a pedestrian, or should it save the life of me and kill the pedestrian, right? And the problem with that kind of question is that there's not an easy answer, right? For instance, the answer to this question is going to depend on your personal philosophy, right? You can, for instance, say that, well, from a statistical standpoint, right, I am probably safer in a car, right, in an accident, right, because the car presumably has airbags and seatbelts and things like that, right? So if the car crashes into a wall, statistically speaking, I'm more likely to survive than a pedestrian is when they get hit, right? Another kind of moral principle that could apply is the idea that, well, I chose to drive or to be in a car, right? I kind of accepted the risk by being in that car. The pedestrian didn't make that decision, so the car should favor the pedestrian. But then there's other considerations, right? Such as like it could say that the car has a duty to preserve the people inside the car, right? That's what it exists for. Um, right. And so you see these kind of significant moral dilemmas that we're asking an amoral agent to partake in. And that becomes kind of a significant issue. Right now, okay, but then you say, well, how about this, right? How about we just make a car have a setting where you can decide that in this scenario, right, I want you to save the pedestrian, or I want you to save me, right? And putting aside the kind of the implications that come with having to select a default for that setting, or just the fact that some people might think that having the option at all is amoral, that kind of binary choice still doesn't account for all of the possible scenarios. For instance, what if the pedestrian is actually crossing illegally? Does that change the equation at all, right? Or, for example, if the passenger in a vehicle is some world-renowned doctor and they're the only person who can cure some disease, right? That will save thousands of lives, right? Well, does that change the equation at all? So when looking at these problems, we're posed with kind of significant questions. So then, from this, right, just kind of applying these kinds of questions of, well, is AI better at doing this job than a person, right, really ignores some of the nuance that comes with moral questions and giving moral decisions to amoral actors. But this, of course, doesn't is not everything here, right? Because there's also an issue of trust. Now, to a great extent, this is a lesser problem, um, and especially a problem that is basically disappearing as AI and automation become a greater part of our life, right? But generally speaking, people trust machines less than people, even when those machines are more are statistically safer, right? And a significant part of that comes to this idea of responsibility, right? So, for instance, if I am driving a car and I hit somebody, it's pretty clear that I am responsible for the operation of that vehicle, right? But when that vehicle is operated by an AI, well, who takes on the responsibility, right? Who is responsible for making changes and ensuring that things like that don't happen again, right? Is it the person that is in the car? Is it the owner of that car? Is it the manufacturer, right? So this kind of natural lack of an obvious agent on who we can put the blame um, becomes kind of a big issue as we move on to a more autonomous future, right? Where inevitably these questions are going to become more common, right? Where machines, whether it be self-driving cars or other, agents, self-flying planes, whatever, right? Uh, as we move to that world, right, this issue of responsibility and who do we blame, basically, right? Who is responsible for making sure that these things operate safely, right, and that there's a certain level of trust with those things, uh, become a big issue. Now, in some ways, of course, this is less of a problem, and it's becoming less of a problem every day, right? Because although historically people have really trended to mistrust automation, right? This is changing. We're seeing these trends. In a recent poll, 70% of people say that they would be okay flying on an autonomous plane, right? Uh, right, that they would have that trust. So this issue of trust is definitely an issue that we can probably as a society move past, but the question of responsibility is still going to remain. So then we get to the second major question, which is the question of who can be trusted to actually run artificial intelligence, right? Inevitably, this is a question that's going to come up because someone is going to be at the top of that food chain. Someone is going to be responsible for that computer, right, for that machine. Um, and who that agent is another kind of major question that we need to address, right? And basically, there's kind of different options, right? First is, of course, naturally like governments, right? Governments should have the power. Uh, Second issue is corporations or private individuals, right? And each of those agents have their own kind of sets of issues that come with that, right? The third question is what regulations should exist and how to actually enforce those regulations. That's another big issue, right? But the more practical question here is the question of how to stop abuse. Because at the end of the day, controlling access to artificial intelligence is significantly harder than just about any other method of control that we have. Because at the end of the day, artificial intelligence is code that runs on a computer, right? I can right now go on GitHub, download some program that runs artificial intelligence, right, or a machine learning algorithm, and run it, right? And there's very little that somebody could do to stop me from doing that, right? So when we talk about controlling who has access to AI, we're really kind of talking about how do we ensure that this technology doesn't get abused, right? Because rogue actors are almost certainly going to exist, right? There's very little that we can do to, for example, stop the government of China from abusing facial recognition technology or developing it, right? Because again, at the end of the day, it's code, right? And even within Western liberal democracies, we see that when you assess the power of this technology, right? Well, they're still going to trend to abuse it, right? As we saw with the NSA scandal in the United States, or just some of the more broader things um, that countries have done with counterintelligence, right? And when you consider the power of the artificial intelligence technology, just their ability to draw connections that otherwise would be impossible to draw, right? It's probably unrealistic to assume that countries are just going to pass that by in a quest of protecting privacy, or in a quest of being a moral agent, just because that great a power just they're not gonna make that decision, right? And not to mention the fact that even if somehow all of these agents decided to be good agents, right, and not develop artificial intelligence, well, then you run into the question that rogue actors are still going to work on it, right? And countering those rogue actors in many ways requires artificial intelligence, right? Uh, Cybersecurity is a big component of this, for instance, right? Where artificial intelligence, right, if it's developed sufficiently, can actually be used to hack into systems, right? And basically, the only way to counter that is to have your own artificial intelligence to block that access, right? Because no single human operator can realistically account for every single scenario that a neural net can, or that a machine learning algorithm can, right? So you see these kinds of issues take shape. And then third, and kind of something that we haven't talked about yet, but is probably one of the most important parts of talking about artificial intelligence, is this issue of economic fallout. Because it's almost inevitable that as we talk about automation, that jobs will be lost as a result. Now, to be fair, there is an economic theory that says, well, that's not really a big issue, right? Because as jobs get lost, other jobs will be created. But then that theory itself is based on the premise that jobs have always been created when disruptive technologies came about, right? And one, right, this kind of scenario is very different insofar as there's not really an obvious candidate for where these jobs are going to come from, right? But secondly, and more importantly, right, um, betting the entire economy, right, and the livelihoods of millions of people on a hunch that jobs will just magically appear, right, seems to be a very responsible economic policy, right? So from this, we kind of get three primary scenarios: one of surplus economy, one of kind of basic assistance, and one of no assistance. But before that, let's extend on this idea of job loss. As I take another sip of water here. So Oxford University did this study, and what they found is that basically anywhere from 9 to 47% of jobs will be lost as a result of automation, right? And this in many ways makes sense because it turns out that a lot of human jobs are about making decisions, right? And decision making is a big part um, of human jobs, right? If your job is sitting in an office and filling in a spreadsheet, well, an AI could probably automate that job away, right? Um, right, which is where we get this kind of significant value about job losses, right? In the same way that, because in the same way that like automation in factories caused job losses in factory work, right, in manual labor, right, and AI is in many ways kind of replicating job loss that we would see um, from mental labor, right? And kind of this quote here from the study largely covers this, which is this idea that it is already largely technologically possible to automate almost any task, provided that the sufficient amount of data are gathered for pattern recognition, right, that can be fed into the machine learning algorithm, as we kind of talked earlier. And when looking at the different types of jobs that can potentially be automated, right, we kind of see these kinds of trends where certain jobs like teaching are less likely to be automated, right? Jobs in engineering, healthcare, are less likely to be automated, but then massive jobs like the transportation sector, which I think consists of like 30% of the world economy, right? Or like food preparation, right? These kind of construction jobs are all jobs that are significantly likely to be automated, right? And from looking at this, we kind of see that there's basically two kinds of jobs that are likely to survive, right? Um, and those are jobs that either one are significantly technologically, require significant technological skill, things like engineering, right, programming, information technology, right, basically taking care of the AI and propagating, right, essentially being a support service for maintaining that AI system, right? But the second job is actually, interestingly, are jobs that require significant emotional strength, right? Things like teaching, right? Uh, Management and politics, right, are all jobs that require significant emotional intelligence, right? Because you're dealing with people, right? And again, this kind of goes back to that idea that, well, AIs don't have a concept of a moral, don't have any kind of a moral philosophy, right? So they're very emotionally unintelligent, right? And insofar as that remains the case, right, those jobs are likely going to still persist. But then we get to the question, okay, well, what happens after job loss, right? And the three kind of scenarios that are most likely to happen according to economists. First is the idea of a surplus economy, the idea of basic assistance and no assistance. So let's talk a little bit about this, right? So kind of the first scenario that gets mentioned, and is frankly probably one of the least likely scenarios, right, is this idea of a surplus economy, right? And the idea is that in a surplus economy, because of all of the automation that takes place, right, human labor is one of the most expensive resources for any company, right? Like the costs of human labor is significant, right? So the idea is that the cost of production is going to become so low that it's going to be virtually non-existent. And from that, right, any kind of basic assistance that the government can provide, right, or uh, any kind of money that a person might have, right, is basically going to be enough to not only survive but actually thrive, right? And this also goes to other kind of technological ideas, things like 3D printing, uh, right, all kind of play a role into this, right, with the idea that, hey, I may only have to ever pay for just the raw materials, right, and all I need to do is just kind of let a 3D printer print everything that I need, right? All of the kind of services are going to be automated by robots and artificial intelligent engines, right? So basically, the idea is that no one person is basically ever going to need to work. Uh, this is probably a very optimistic idea, right? Because it's very unlikely that, at least anytime soon, we're going to find ourselves in a scenario where A, no one has to work, but B, right, everything is so cheap that it's essentially free, right? And that nobody really needs to get money to survive or anything like that, right? So it's very unlikely. Um, so probably the more likely scenario, right, at least in the Western liberal democracies, right, is this kind of middle of the road option where there is some base assistance provided by the government, right, which they get through taxation and automation or what have you, um, right, which allows you to sustain some sort of a minimum living standard. It allows you to, put food on the table and survive, right? But this assistance is very basic in its essence, right? A job is still necessary to afford a comfortable living standard. And almost certainly in this kind of scenarios, the limited jobs that do exist are going to have massive competition, right? And this creates a lot of opportunities for things like nepotism, right? And corruption, uh, and other kind of issues where people that are, right, in income inequality, right, where people that have jobs are probably going to be the people that are going to have most of the societal capital, right, to survive and control society. Um, And this is a significant issue, right? Obviously, as we look to kind of creating a more equitable society, right, this is in many ways a regression off of that. Um, that is vastly problematic, right? Especially as we look to trying to create an equitable society. Um, and in many ways, this is the most likely option, right? Because of the fact that it's very unlikely that we're going to create a surplus economy. And insofar as that's the case, right, we're going to require some basic assistance, which in Western liberal democracies, right, they're probably going to provide, because we do see the idea that, like, the idea of a welfare state already exists in some form, right, as a form of basic assistance. Now, of course, the worst case scenario is no assistance, right? Essentially the government just says, whatever, like, figure it out on your own, right? And this is going to create almost certainly massive job loss without any assistance, right? This is going to likely lead to an increase of, for example, underground markets and other illegal trades, right? Because when people don't have the ability to earn an income, right, they're almost certainly going to turn to less legal forms, right? Everybody's kind of going to have their own hustle wherever they can. And if they don't, right, this potentially leads to some of the kind of deadly effects, right? Those effects include things like starvation, right? Lack of medical access, or even stress-induced illnesses and diseases, right? That will lead to shorter lifespans, right? That lead to kind of just generally like a virtually non-existent standard of living, and ultimately limit their ability to even attain an employment, right? So we see this kind of as the worst case scenario. Now, then it's important to talk about, as we talk about the economic impact of artificial intelligence, it's then also important to discuss how this might impact developing economies. Because ultimately, when we consider developing economies, right, these are economies that are, at the end of the day, going to be the most vulnerable to any sorts of economic disruptions. Right, obviously, developing economies usually have lesser budgets for things like social assistance. Right, they have less of a safety net for handling these sorts of economic disruptions, right? And this sort of scenario will likely only further any disparities that already exist in the status quo, right? It will only drive developing economies kind of further, it will only further bring them down, right? Because of the fact that they're going to be less able to survive within this wide scale economic change. But also, it's important to note that there is kind of a bright line here, right? And that bright line is the fact that due to the investment required to actually attain artificial intelligence, any effects, right, are likely, like, these economies are likely to be the last to see these changes, right? Why is that? Well, right, when you consider the fact that the investment required to develop robotics and artificial intelligence, right, this investment is much less likely to happen in the developing worlds. And although on the world scale, right, they're obviously going, the disparity, right, is going to be driven, regardless, right? When we consider the micro level of economics, this change is likely to be to arrive later than we might see it in the liberal world. Oh, how did this get here? Right, of course, but naturally, right, as we come to debate, discussions of debate, right, this sort of thing lends itself naturally to a Marxist extension in the form of either creating a surplus economy, right, the Marxist society, or even things like accelerationism, right, this idea that we should just let everything collapse, right, and this will start a Marxist revolution, right? Of course, this is, I think any economics debate ends with a Marxist extension somewhere in there. But either way, that's my spiel. So, any questions?
Yeah, I think since less people, I think I have one. In terms of when you talk about the idea that when people are, let's say, giving their labor, they are basically exchanging their time for money, right? But
Mhm.
in the case of automation, the time of human beings and simply is not important. So in that terms, how do you think that economy in specific businesses will shift when that services would, like, they do not really have to provide those services to people?
Yeah. So that's certainly an interesting topic of discussion, right? And I think that a lot of that kind of changes, right, to where we move to an economy that is based on less so on the idea of trading time to the idea of trading certain economic output, right? And in some ways, we're seeing that already, where companies are kind of changing their traditional, pay X wage per hour model to the idea that, hey, I don't really care how much time you spend on this, right? Is so much if I have this program at the end of the day, right? We're seeing this kind of development in high tech sectors. Um, and I think that with the development of artificial intelligence, right, and the transition to um, less of a time based economy, this is something that is only going to be further propagated into other sectors of society. Although that said, of course, there's always probably going to be jobs that are time based, right? Things like teaching, social services, um, right? Caring for the elderly. Obviously, these things are probably still going to maintain some of that reminiscence of exchanging time for money, but in other kind of more results driven areas, that is probably a transition that we're going to see.